Assalamu alaikum warahmatullahi wabarakatuh. Welcome to another computer science lecture. Today we are going to start section number 2 of our new syllabus, that is data communication, and today we are going to be discussing section number 2.1.1, methods of data transmission. Whenever data is to be transmitted, so it is never transmitted in a continuous stream. Whenever data is to be sent over long distance, especially, it is usually broken up into tiny chunks or pieces called data packets. Why? Because sending a file in one piece is difficult to manage, it is difficult to send, it is difficult to make sure that there have been no error or alteration during the transmission, whereas breaking it down into tiny pieces, into small pieces, and then sending those pieces is easier to manage. So the packets of data are usually very small. They are typically not more than 64 KB bytes. So they are much easier to manage and control rather than a long continuous stream of data. Now, for example, if you have a file of 6 MB, that basically means it has 6 multiplied by 1024, 6144 KB bytes or KBs. Now, if one packet size is 64, so that basically means that there would be 96 packets which would be sent. They would be numbered 1 2 3 4 up till 96. Okay, but so this is how packets are broken down. All of the packets, they need to be reassembled at the destination for the message to be decoded. All the packets that are sent, they are received one after the other by the receiver, and then the receiver puts them back together in one big file, and then the message is decoded. A data packet is also known as a datagram. This is a rather very old name for it, but the Cambridge still accepts it. Now, what is the structure of a data packet or a datagram? The structure is like this. There are three parts: a header, a payload, and a trailer. Now, inside the header there are four things: the IP address of the source or the sender, the IP address of the destination or the receiver, the sequence number of the packet. Like we discussed over here, that if there is a file of 6 MB, it would be broken down into 96 packets. So all of these packets, they need to be numbered: packet 1, packet 2, packet 3, and so on up till packet 96, so that the receiver he can put together all the pieces just like a jigsaw puzzle in the proper sequence, and then merge them together in order to receive or make the correct file. If the packets do not have a sequence number and they are joined together in any other combination other than the original combination, then the message can be altered or it may become corrupt and totally unreadable. Lastly, in the header, the size of the packet in bytes, that what is the size of the current packet, is mentioned. The payload is the part where the actual message lies. It is of 64 KB bytes and it contains the actual message which is to be transmitted. And lastly, the trailer contains two things: a method of identifying the end of the packet. It contains a string of binary or a string of code that by reading which the receiver knows that okay, this packet has ended over here. And then there is some form of error checking method to ensure that this packet has been received successfully without any error. For each packet, the packet header consists of sender IP, receiver IP, sequence number, and packet size. And the header often also contains another value indicating how many packets are there in the total for this transmission. Now this rule or this thing is not followed by all the packets or all the protocols, but these four things are always there in each and every header, whereas some packets or some protocols have this optional fifth part. And the payload consists of the original packet, which is about 64 KB bytes. And the trailer has the identifier for end of packet and an error checking method. Now an error checking method to make sure the packet has been received successfully, we use a CRC method, Cyclic Redundancy Check. Now how this method works, it is a part of your syllabus. This involves the sending computer adding up all the 1 bits in the payload. Inside the payload, the number of bits which are not the number of bits, the bits which contain a value of 1 or all the 1 bits, they are added together, and after binary addition, whatever value is found out, that value is converted into a hexadecimal number, and then that hexadecimal number is stored in the trailer before sending. When the packet arrives at its destination, the receiver recalculates this process. The receiver adds all the ones together in the payload and then converts the answer in hexadecimal, and then the receiver then compares this value with the one that is there in the actual packet trailer, and if the two values are same, then that means no transmission error has occurred. The next thing which we have is packet switching. Whenever a packet is to be sent, then a router is a device which plays a key role in it. A router receives basically whenever a computer needs to send a data packet or a whenever a computer needs to send a message, then the computer sends that message to the router. The computer breaks it into data packets and gives those data packets to the router, your internet router or your internet switch. Then what does that router do? It calculates a possible path from where the data packet can travel inside a network and how it can reach its destination. A router calculates two things: the shortest path for sending a data packet. For example, if we have to send a message from A to B, then what can be a shortest path? 1, 2, 3, 4, 5. This has to go with 5 routers, and if we go like this 1, 2, 3, 4, that means this can be the shortest path. So these calculations are made by a router, that from which router should I send the packet. Each packet is assessed. For example, the router can also send it like this: 1, 2, 3, 4, 5, 6, 7, 8. The router can also send it like this, but this would mean that there would be 8 routers, or this would be a very long path. So the router calculates the shortest path for sending a packet, that how can I send a packet with the shortest possible number of routers in between, or the shortest possible path, and as well as the optimum or the best path for sending that data. Like for example, we saw 1, 2, 3, 4, this would be the shortest path. But what if over here the network is already very much crowded? What if the router has already sent 16 packets through this route? In that case, the router is not going to follow this path. Instead, it is going to follow maybe this one. It contains 1, 2, 3, 4, 5. This route is a little longer. It has one additional router in between, or one additional device in between, but this path is empty. If you are going from one place to another, you don't just calculate that which road will take me over there in the least possible time. You also see that on which road there is a traffic jam and on which road there is not a traffic jam. Like for example, if you need to go from, let's suppose, Drake Road station to Sadar, then obviously you would choose SHA-FSL. But what if the SHA-FSL is tightly packed? There is a huge traffic jam or some power show going on. Then obviously you will have to go to Millennium, and from there you can go to through the National Stadium Road. You can go to Sadar. You would have a longer way, but at least the road would be empty, so you would reach early. So this process is known as packet switching, that deciding for each and every data packet that how can it be sent through a shortest possible path and through the best possible path. It is a method of data transmission in which a message is broken up into a number of packets. Okay, each packet can then be sent independently from a start point to end point at their destination. The packets will need to be reassembled into correct order using the information sent in the header. At each stage in the transmission, there are nodes that contain a router. Each router will determine which route the packet needs to take in order to reach its destination. Okay, like for example, there is a message of a 120 kbs or 320 kbs. So by the rule of 64 kb, there would be 4 packets for it. So that basically means that 1, 2, 3, 4, 5. There would be 5 packets. Now, or wait, I'll just draw them using different colors so you can understand. So 1, 2, 3, 4, 5 packets. Now when these packets are sent, router A is going to receive all these 5 packets. Then let's suppose for this black packet he decides router 2, router 1, 3 and 4, and the first packet arrived. Now for purple router, it goes from here till here, and router 2 decides router 1 is busy, so it may send it to router 5, which is going to check that out of all the possible paths, which is the free one or which is the shortest one. It may send it to router 8, router 8 may send it to router 7, then router 10, and then it is going to reach router B. But maybe meanwhile this third packet might have already been reached. As you can see, it was first, second, third, fourth and fifth: black, purple, sky blue, orange and green. Whereas over here black is received first, then orange, which was the fourth packet, then sky blue, which was the third packet, then purple and then green. Okay, so that basically means that the packet can reach, because each router decides where to send the packet to, the packets can reach out of sync or out of order. The first one may reach at third position, or the last one may reach first, or the third one may reach at fifth position, and so on. So it is the work of the router or the computer to reassemble all these packets, and for that they need this part, sequence number of the packet. Okay, now why do we do packet switching? The benefits of packet switching are that there is no need to tie up a single communication line. There can be multiple options. When the packet, wherever it would find a possible possibility of traveling, the packet will go from there. It is possible to overcome failed, busy or faulty lines by simply rerouting the packet. If let's suppose there have been a breakage between these two routers, then this router can simply detect, okay, whatever packet I am sending over here, I am not getting any acknowledgement for that, so the router can simply send it via this line from here like this, instead of sending it this. So it is easy to reroute packets instead of losing them. It is relatively easy to expand package usage, means you can send more packets at the same time. While packet 1 is traveling from here, and here, the rest of the nodes or routers are free. They can be used to send packets simultaneously. And a higher data transmission rate is possible because you are able to send more than one packet at the same time. Now there are some drawbacks of this as well. Packets can be lost and need to be resent. This method is more prone to errors with real-time streaming. For example, if you are watching a live sporting event, or if you are on a live video call, and if the packets reach you out of sync or not in the proper order, then you are going to have a lot of lagging in the video call or in the video quality. There is a delay at the destination whilst the packet are being reordered. When the destination when the computer is reassembling the packets, so there is a little delay between getting the message and actually being able to open it. So what happens is that since each router decides where to send the next packet, then sometimes what happens is that the packets are sent too far away and from R4. Okay, like see, this packet has traveled almost the whole network. This is a waste of resources. We do not want our packets to randomly travel from one router to another endlessly. So what we do is, some packets are get lost because they keep bouncing around from router to router and never actually reach their destination. How is that made possible? For example, the packet came over here, then it decided that this path is free, this router decided this path is free, this one decided this is free, and then it decided this is free, this one decided okay this is free, then this one decided this is free, this one decided okay R3 is busy, R8 is busy, so this is free, and then it sent it over here, and then it sent it over there, and then over there, and then over here, and then over here, then over there, then over there. See, the packet is basically moving in a circle because each router independently decides on which path to send the packet. So sometimes the packets are stuck in a loop or a circle. Instead of reaching the destination, they keep on moving in at the same place or between a few routers. So in order to prevent that, if this keeps up, lost packets would mount up, clogging the network. They are going to eat up all the available resources in the network, and every line is going to become clogged or traffic jammed. To overcome this, a method called hopping is used. A hop number is added to the header of each packet, and this number is reduced by 1 every time it leaves a router. Each packet has a maximum hop number to start with. Once a hop number reaches 0 and the packet hasn't reached its destination, the packet is deleted when it reaches the next router. The missing packet will then be flagged by the receiving computer, and a request to resend these packets would be made. It works like this. This is how packet hopping works. So this is the first router to send the packet in a network, and over here this is the starting number, let's suppose 10. Now from router 3 it went to router 5, router 8, router 11, 15 and 21 and so on. Each time the router makes a hop, then the hop number is decremented or decreased by 1. If the packet reaches 0 and it has still not reached its destination, then the packet is simply deleted without any consent whatsoever. And then at the receiving end, when the receiver is rearranging all the packets, the receiver is going to know, okay, packet number 15 is missing, so it is going to send an acknowledgement message to the sender that please send packet number 15 again, I have not received it. This is how packet hopping works. Now these are some practice questions. The trailer in a packet will use one form of error checking. Explain what is meant by a CRC, Cyclic Redundancy Check. The payload contains the following data. Use this data to show the receiving computer can verify that the received payload was error free. Okay. And question number 2, explain how is it possible for packets to be lost during transmission. Describe how it is possible for a system to deal with lost packets, and explain why you think packet switching might improve data security. These are exam style questions, so try to attempt them and let me know that if you were successful in attempting them or not. I'll post the answers below in the description. I'll see you guys in the next lecture. Take care. Allah Hafiz.